Hello, everyone. This is going to be a nice and easy talk for the end of the day. I'm sure everyone's well aware that I'm the only thing that stands between you and the party keynote. So I'll make it, I'm not going to say I'll make it snappy because it's still going to be 45 minutes, I'm sorry. But let's get into it. My name is Mike, and I'm here to talk to you about something that sounds very cryptic, because I didn't go into much detail in the title, but the whole point of it is to tell you what you can do versus what you should be doing, and what, more importantly, you shouldn't be doing. The goal of this is not to teach you new tricks, because that's what all of the other talks are for. And I'm sure you already know a lot of tricks, how to do everything, how not to do everything. This is more just to go through and get you thinking about the sort of questions that should be popping up in your mind when you're making decisions in your code base. And to help you lay all of those tricks that you already know, sort of in an orderly manner, in an orderly fashion in your head. We're all people here, so probably don't know who I am. So I'll introduce myself first, briefly. This is where I'm from, Sydney, Australia. Well, not actually from there, but that's where I live now and work. From there, originally. I'm sure you've never heard of it. It's never in the news. I work at Kotlin, and not a lot of people have heard of it because it's a very specialized industry, I guess, that we're in. But it's quite a large company. We're in the medical industry. We make cochlear implants for people who are profoundly deaf. So everything that goes with that, the software, hardware, the firmware. So it's a really interesting place to work. And the main office is in Sydney, which doesn't happen often because all of the main offices are usually here, which is not ideal. And I'm the Android tech lead there, which is another benefit because I get to choose what language we use. And I'd like to say that nobody can say no, but a lot of managers can say no. And I organize the Sydney Kotlin user group. So just to get you some background on me and Kotlin, I've been doing it for about 3 years now. So my first article and talk about using Kotlin for Android was in 2014, I think. And this was back when you get into a room and you ask people to raise their hand if they've ever heard of Kotlin, and there's silence. There's just crickets. And when you get to the end of it, everyone's like, well, what's the point of that? Just use Scala. So now I'm finally in a room with more than 10 people who know what Kotlin is, which is great. Really excited right now. With that done, out of the way, so let's focus on the actual talk. I'm going to start with a background because it's, like I said, it's not really a traditional thing to be talking about. So I want to give you my sort of mindset when I decided to do this talk. Then I'm going to show you some reasons why this talk is even needed, so with the potential for the problems that we're going to see. The real-world issues, so the actual things that I'm talking about. Then some perspective, and then we'll wrap up. So let's get into that. Background, how did this talk come about? And like I said, knowing this helps where I'm coming from. And the way that I think about it is there are always stages in which you learn a new language. So regardless of whether you picked up the first language, so you've never done programming before, or maybe you've done something at university, or you're already a seasoned developer and you're thinking of picking up something new. So here are my 5 stages. Your actual number of stages may vary. Could be more, could be less than that. And I promise the 5 didn't come from the fact that I found that picture. It's related, but not just based on that. So number 1, you're reading the Get Started guide. This is maybe, if it's a hyped up language, maybe you've seen it on Hacker News or something like that. Everyone in your company is talking about it, and you go, okay, this is pretty cool. Maybe I'll look into this. And at this point, you're noticing things like the syntax, the features. Maybe it's a language that you'd never touched or nothing in that sort of vicinity that you touched. Maybe, like with Kotlin, it's designed for the same things, but it's a different language. So you're looking at the pros and cons, what you're trying to solve by moving to that language, things like that. At this point, your investment is 0. So you're not invested in it. You could still give up any minute. Then you proceed to stage 2. At this point, you're installing the tools, you're running the code samples. Now you're actually getting your hands dirty, actually doing something in the language. At this point, there's some commitment to it, but this could be the stage that would be the last one. So if something, how many times have you started learning a language and it looks fine, but then you try to implement something concrete in it, or even start doing something concrete, and you go, ugh, it doesn't even have this. Okay, never mind, not interested anymore. Then you proceed to stage 3 if you are interested. At this point, that's what I like to do anyway. At this point, I set myself a superficial goal, maybe an existing app or an existing, I don't know, command line tool or something like that I'd already done before in another language. I set that as my goal, and I start implementing that in the new language. So that's where the frustrations start, where you go, but in that other thing, I already wrote it in this particular way. Why can't I use that insert feature here? And that's where, like I said before, that's where the honeymoon could be over. So first frictions, you may not go to stage 4. Stage 4 is an interesting one. At this stage, you know enough about the language that you can solve really simple problems with it, or medium kind of difficulty problems with it. And at this point, you're like, okay, I can take this. Maybe I'm going to write code that's not idiomatic, but I'm still going to do it. So I call it either JavaScript stage. I'm not going to go into it any further. If you know what I mean, you know what I mean. If you don't, I'm sorry if I'm being rude. And another one that's expert beginner stage. Who here knows about the theory of expert beginner? Yeah, so some of you. For those of you that don't, Eric Dietrich wrote an interesting article a long time ago, I think 5 years ago, about the concept of the expert beginner, where the standard progression of people doing software development, they go from beginner to sort of mid-level, then to advanced, then to expert. But some people, if they're in a particular company where they're the most senior person there, or they don't have enough mentorship, or if it's just what they're like, they sort of graduate to this expert beginner stage where you've done it long enough that you think you're an expert, but you haven't actually dug deep enough to be an expert. And that's the sort of stage that's dangerous, because a lot of people stop with that stage. But this is where we are for this talk. Stage 5 is for people who are wondering, I can already do this, and I know all of the features of the language, because it's not really like some languages where the features just keep on coming and keep on coming. You can learn all of the features of Kotlin, and you can be quite confident in it. But this is the stage where you go, which one am I meant to use? They do very similar things, or I'm doing this because I was doing this in the previous language. Am I still meant to be doing that? And that's where you start wondering. And also, this is not really specific to Kotlin, but the next point is, Kotlin is one of those languages that people move to from, let's say, Java. And it's more concise, so when you write a new application, it's kind of like a car, like a new car that you just bought that still has the new car smell. And if you have a legacy code base in Java, you're going to go, maybe your project manager is, behind you, and they're like, you have to finish this. So you're not going to care that much if you make a shortcut, because you know that the legacy code base is legacy. It has a lot of shortcuts already. So in Kotlin, when you're rewriting or when you're writing a new application in it, you're going to be more careful about that, because you're going to go, don't spoil this new cool thing that's all pristine and smells like a new car, basically. Except the problem is that sometimes there's a potential for problems. It's not really specifically, it's not because of the design of the language, and it's definitely not because of the language, but certain factors make Kotlin susceptible to these problems. So let's look at some of these. First one is the kid in the candy store syndrome. This is when you've come from a language that's very restrictive. So again, I'll use the same example, Java, especially if you're an Android developer. How many Android developers here? Everyone, fair enough. If you've come from Android and you're converting from essentially feature set of Java 6 with a little bit of Java 7 backported into it, when you start using Kotlin, you can see a lot of the things that you haven't seen before. Or at least you've seen them before, but you've never had access to them. So you're not sure whether you need to use them, and you're not sure what the downsides of using them, because you can just kind of run off in the distance and try to use all of them. Second one is very important, so I want to spend some time on this. Kotlin is not opinionated. It's a language that's designed for, well, I don't know, I guess the JetBrains guys would know this better. I don't know whether or not it's designed for that, but it brings together a lot of audiences. So it brings together the mobile audience with Java, it brings together the back-end people, the front-end people. So it's kind of there to cater for being at least good enough, or at least pleasant enough for all of those people. So you can't really make decisions like, for example, like the Go language, where you don't like these options, these very limited options that we've set out for you, tough. This is what the language is. The good side of it is that at least you don't wonder about whether or not to use something, because if you have this thing to solve, this is how you solve it, regardless of whether you like the code or not. And programmer is a creature of habit. So when you're coming from a different language, you're going to bring practices, whether you like it or not, you're going to bring practices from that language. Even if you're trying to be very, very persistent with only writing idiomatic code in this new language, you still, in most cases, you've had years and years of doing other languages. So your main one, you're going to bring that baggage with you, which is a potential for a problem, because then you start creating code base that's basically, Java written in Kotlin, or Go written in Kotlin, or Objective-C, whatever it is. There's obviously the time pressure, because it's one thing when you're writing something for a pet project. And I remember there was this statistic somewhere, I think Stack Overflow had it, I couldn't find it before, where the languages were categorized by how often do people use them in production, and how often do people use them in their own spare time. And the spare time ones were all the Haskells, all of the Common Lisp, and things like that. And I think Elixir and stuff like that. But all of the production ones were the Javas, the Objective-Cs, the Swifts, and things like that. And that's going to change the behavior, because when you're under time pressure, you're going to rely on, well, first of all, you're going to rely on all the documentation you can find. And what is the first thing you do when you face a problem? You Google it, and in most cases, you're likely going to find it on Stack Overflow, which is nice, but that's also susceptible to basically anyone posting it early enough, and then kind of a confirmation bias where the person goes, oh yeah, that worked, okay, I'll accept it. And then for all of the future generations who are looking at it, we see this in Android quite a lot. When you see an old response that's the accepted resolution to a problem, that's something that should never be done. It's literally the worst solution ever. And then there's going to be somebody commenting and saying, like, it's 2017 now, 5 years after that was posted, you shouldn't use that, but tough. And there's the, if it ain't broke, don't fix it kind of mentality where if it doesn't bring any business value, you're not going to be allowed to work on that feature in a lot of the companies. And the last one is not really, again, the fault of the language. It's more just the age of the language. A lot of the documentation that's currently in existence is more, this is how you can be doing things. Not so much, stories from the trenches. If you do this, then this happens. If you don't do this, this happens, which has been a thing in Java for years. But since Kotlin is only just emerging now, a lot of the tutorials, a lot of the documentation is more excited, now I can do this new cool trick. Now I'm going to teach you how to do this cool trick. And like mentioned in the keynote and the morning sessions, there's still a lack of certain things like Sonar with the static analysis and coding guidelines. That's something that I found out this morning will be added, which is nice. So that makes some of the slides in this presentation obsolete. So let's look at the real-world issues. Probably thinking, even though it's the last presentation for the day, get to the point. Enough of the background stuff. And I didn't want to say real-world problems, because they're not really problems. They're, like in Jira, you don't have problems, you have issues. Kind of like that, where it could be problems, but not necessarily. I'll preface that with a warning that my examples are basic, and read them as terrible. Because every time you come up with an example, you're like, right, you need to make this as wide of a reach as possible because you're going to have Android people, you're going to have non-Android people, and they're not going to share the same problems. So you start thinking, okay, so have a string, then I convert the string to an integer, and okay, and I print it. That's an example. So use your imagination to make it relevant specifically for you, and try to get to the bottom of the message that I'm trying to send. First one is a simple one. So shadowed variables. This came out of an actual conversation when somebody who came up to me, who's an Android engineer back home in Sydney, who's never done Kotlin before. So he started doing Kotlin when it was announced officially by Google, first-class support. And his main question was, how do you deal with nested it statements? I was like, what do you mean? He said, well, how do you know which it you're referring to? And my point with that was, why do you even have nested its? You're asking the wrong question. So I decided to add this as a kind of as a warm-up. So let's look at an example. This does very little. So again, with the examples. But you have the point of it is that you have 3 levels of lambdas in there, all inlined by 3 levels. So technically, this compiles fine, and this works fine. And arguably, some people can say, if you're only using the lower level, it doesn't matter. Just continue using it. But this stops making sense after about 5 minutes after you've written it. And this is a really, really basic example that I just magically conjured. This is going to be much worse if you have RxJava or whatever other asynchronous way of dealing with things that you have, like coroutines. And this is 5 levels down into your class, into your method, into a class of a class, and so on. So even this one is made much better by just quite simply adding names to it. Now we know what each level is. Second one is more controversial. So this is about shadowing variables in general. A lot of people say, you're not meant to shadow variables, and in fact, when you're in your IDE in IntelliJ, oftentimes it will highlight it saying that, in this case, update adapter, you have the class adapter and you have the method adapter. It will say you're shadowing a variable. A lot of the people will say, who cares? we know that this is specifically this dot adapter, the other one's adapter. And I tend to agree that this isn't as critical as the first one. It's not as critical as the it example. But even that, my point is, even then, it makes more sense to do that, even though it's a lot less critical. Let's look at another example. Opportunistic extension functions. This is something that you only get to when you've had some time developing in Kotlin, you've had other people on your projects, you have a team of maybe 2, 3, 4 people, and you start seeing these artifacts. You start seeing these things where somebody's committed the code, maybe other people code reviewed it, so you haven't seen it until now, and you start seeing these things where the kid in the candy store things that you're excited about are being abused. So, not trying to say that extension functions are bad, not at all. Extension functions are awesome, and they're really powerful, but they're for extending functionality of an object. So think about it as a test. Ask yourself, if you're going to add a function, an extension function, would you have added that function to the object itself if you didn't think about the composition of it, if you didn't think about that? Does it make sense? Is it actually, if it's a extension value or extension variable, then does it actually make sense? Is it a property of that object? And is the thing that's happening in the extension function, is that actually something that's happening to that project, to that object, sorry. So let's look at a simple example. Here we have a 2-hex string method inside of an integer. Perfectly valid, right? In this case, all of the things that I said before, they work. We have a toString thing in most of the objects, and why not have a 2-hex string? So in this case, it is a property of something inside of that object, and you're printing it out. Example 2. This one's very specific of Android, but if you don't understand it, it's not really that bad. So in Android, you have the context, which is kind of like a God object, where all of the resources, all of the things, all of the references originate from. So whenever you need something from anything, you have to bring the context. And there are things that are called system services, where you invoke them from that context, and they allow you to do something. So layout inflator helps you inflate XML files into layouts. That's basically all you need to know about that. Except the problem is, in the standard Android API, you just invoke them as context.getSystemService with the name, and it returns it as an object, or in Kotlin, as an any. And a lot of the code bases do this kind of a shortcut thing where they just have extensions of context.layoutinflator, context. Whatever other services there are, like telephony services and things, which in my view is acceptable as well. But this is where you start drawing the line, where there is an alternative of just doing a utils class, well, an object in this case. But the first one is perfectly valid as well. But this is kind of the line where if you stray further from that, it becomes a bad idea. This is an obfuscated version of actual code that I found. It's kind of an intern code, as I like to call it. So you'll see that it's a complete abuse of the power that extension functions give you. Dmitry wants to say something.
Yeah, I just want to say that the official position of the Kotlin team is that this is the perfectly fine thing to do, as long as you make this function restricted scope. Make it private.
Right.
Then it's okay to do it, and this is not.
Right. So Dimitri's point is that it's perfectly fine to do this. The official position of JetBrains is that it's fine to do this as long as you make it private, which is a good suffix to that. My point was that this was in the top scope, and it basically fails the test that I drew up before. The thing that you're extending here is a string, which is just a context or path in this case. Don't want to use the word context to avoid confusion. And you're injecting it into something else. So that whole test is completely non-existent. And the fact that the thing that makes it worse is also the fact that you're extending something that's a very common type into something that's very specific to only this project, so only to this code base. So same as before, easy way to improve that. More along the lines of my last point is the opportunistic top-level functions in general. So this is relevant for my previous point as well, but it's even more relevant for just regular top-level functions. So if you have a function that's called copy or something like that. So in Kotlin, there's standard functions like that where you have the run, the apply, which is fine because they're useful for basically every context. They're essentially part of the language. But if you're doing things like before and you don't define it as a private, then you're running the danger of just polluting your whole autocomplete space. Let's look at an example. So let's say you're working on a database application for some sort of a media company that has movies, TV shows, documentaries, things like that. Some company like that. I'm not going to name names. And then you have your file that contains all of the movie-related stuff. So all of the other code samples I was shortening, but this is the file. So let's say this is the top-level file, your movies.kt. You have the client API keys for your movie source. You have a get item for some sort of an adapter. You have a copy for exactly that adapter. And you even have a debug movie details method in there. Then you're switching to another context. You're done with that. Now you're starting to write some TV shows adapter that deals with other types of media. And then what happens if let's say you've started implementing the init constructor, and you press whatever the shortcut on your computer would be to display autocomplete. And then this happens. And in addition to all of the stuff that's meant to be there, you have all of this stuff that's completely unrelated to anything else. And basically at this point, autocomplete becomes useless because you're just sifting through the stuff that's not meant to be there at all. Again, it's not a fault of IntelliJ, it's a fault of your own. Because you didn't encapsulate it, you didn't make it private, you didn't target it to specific objects, specific classes, things like that. Inferred types, that's another thing that I'm going to preface with a comment that some of the stuff that was announced this morning, or I saw in some presentations from the JetBrains guys, sort of makes this a little bit watered down, this point. But my point is, I started writing Kotlin, like I'm sure a lot of you, and basically trying to purge every single type that you can get rid of. That makes it easier, it makes it cleaner, because in a lot of the cases, you're just basically writing Python. Like, yep, val, this thing, assign it to that. And then as the project, because we started a new project from scratch, we weren't converting Java code. And after a while, it grows bigger and bigger and bigger and bigger, and you have these 3 layers of abstraction where this is the database, this is some asynchronous thing that you have, this is a service, and you're faced with a bug, and you want to click through things to just remember how you implemented it or how somebody else implemented it, so you wouldn't remember how to do it. And then you suddenly see this whole chain of methods that don't have return types. So let's see an example here. Completely trivial example. You have 2 variables that are really clear-cut primitives. It's fine. That's what we want. That's why we have type inference. Third one gets a little bit like on the line where, yeah, it's payload because it's called payload, and you're getting it from some factory, but what if you have different types? So what if it's a polymorphic payload? You're not sure anymore. The fourth one is a complete mess, at least without the plugin changes where it will say what it returns. And even then, if it goes to a completely different function, it could be a lot more specific in what it returns. So you may want to just say, I'm returning a payload rather than a default payload or things like that. So first two, completely fine. Third one, much improved with the default payload, because there were you just thinking that it was just regular payload. And the fourth one, another point about that is that whether it's nullable or not, that's something that can sometimes catch you by surprise. So maybe you're doing a let on it, or maybe you're converting it from somewhere, or maybe it's Java code that you're interacting with that doesn't specify nullability, although in most cases you will get a warning about that. But point here is, don't do what I did before, where you just remove the types from everything because now you don't need them. Borrowing from other languages is an interesting one because, like I said, programmers are a creature of habit. So we all come from different backgrounds and we all know different languages. And I kept hearing, people in my team, other teams going, how do you do this? How do you do that? Naming all of these features that came from other languages. And I wanted to sort of cover that. It's not really, this is all highly opinionated, by the way. So if you don't agree, that's completely fine as well. My take on it is, it's not necessarily a faux pas to adopt something from another language. Just don't break the intentional design. If something's missing from a language, in some cases, it's not an oversight. It's a very conscious decision on the part of the designers of the language. So this is the example that this came out of. How many of you have used Go before? Okay, more than I expect. So Go has this notion of defers, where you can run, so if you're opening a file and you want to make sure that you don't forget closing the file, you go defer the closing until you're done with all of the other stuff, which makes sense. And actually, it's not even that difficult to implement it in Kotlin. This is partially stolen from Andrei's sample implementation in one of the forums or Stack Overflows or something like that. Basically, with DSLs, you can just do that quite easily. Completely fine. What's not fine is something like this. I'll just give you time so that it sinks in. Because keep hearing people go, why isn't there a ternary operator in Android? I mean, in Kotlin. Because people moving from Java, they're used to the question mark, colon notation, but it's not readable. Every time you go to a forum post or something like that where people ask that, there's going to be somebody from JetBrains going, that's a conscious decision. It's not just an oversight. There's a reason why we didn't do it. But technically, Kotlin is flexible enough to let you do that. You can do that. I mean, it doesn't let you override the operator, just any operators like Scala, where you can override any letter of the alphabet or any symbol, but you can still do the yes and no. And technically, nothing's stopping you. Oneliner functions is kind of a related one, because kind of related to the typing point, actually. And it's now encouraged in 1.2 plugin, as I noticed, because I updated and it started highlighting everything, saying that if you have a function that only has one statement in the body, it will say, make it into just one line equals to the body. But there's a real danger in that, because let's say you have this. Let's say you have a remove listener function for any old context, doesn't matter what. And then you're removing something from the list of listeners. At this point, the return type is unit. And then you do that. Except the return type is no longer unit. It's the thing that you're removing, basically leaking that object. And now the user can do whatever they want. They can store it. They can do whatever. So the better way of doing it is either that, or when we were talking about this at work, somebody who, so this is the first solution. Either do that, or another thing that somebody who does F# suggested, and this is another borrow from other languages point, do that, where you implement an ignore, where it just returns a unit So technically it works, but I don't know, not necessarily as pure. Last concrete example that I'm going to look at is something that I've already written an article about, but only various bits of it. So when you have multiple things that do exactly the same thing, how do you choose? So if you have two language tools that get the same stuff done, how do you choose? So let's play the same or not the same. I actually have no idea how the deal or no deal is played. I only know the logo. So the first one that I used in the article, if you have just a for loop with indices, you can either do indices and for I in the range, or you can do a forEach in the range. And we had a massive nerd argument at work about this. Let's decide which way are we going to use this. But if you decompile this, there is slight difference. So it's not really necessarily a massive difference, but you can see the first one is exactly the same thing, only in Java, well, in decompiled Java. Second one allocates two objects. Not a big issue, but to tip you one way or another, maybe enough. For lists, is it the same? So you're going to go, okay, fair enough, I'll use the first one. Is it the same for lists? Not really, because now you're instantiating an iterator anyway. So that argument doesn't really hold. So our coding standard basically goes, if it's indices, use that. If it's lists or anything that's already iterable, use that. This one I'm going to kind of glaze over because that's a common one that people say, yep, the JetBrains guys know what I'm talking about. Is it the same to say with or apply? And basically, yeah, it is. But the difference is that one you can make an optional call to, the other one expects it to be non-null. And that's where we're starting to get into the, is it just the decompiled code that you should care about? And this one's very much that point. So the top one is basically the Java code written in Kotlin. You're iterating over something, and your point is you want to find all of the even numbers and print them. Again with the strings, again with the printing, I'm sorry. But the first one just iterates over them and finds it and prints it. Second one uses the functional approach that Kotlin now allows you to do, where you go filter and then forEach. So the second one obviously looks a lot more readable, but that doesn't support it. So if you're just going by my first points, and you're saying, are we just going by whichever one's longer and instantiates more objects, then it doesn't really work. So that's when you need to find a balance between the two. And by the way, how many of you have decompiled Kotlin before? OK, so I'll probably skip the part where I wanted to show you how to do it, but I'm guessing most people, I'll probably just quickly go through it. So you can find it you can find your class in the build directory. Sure, there are better ways, but this is how I do it. Then you select the class. It will produce this sort of cryptic thing that doesn't really help. Then you hit that. You go decompile. And then you get this nice stuff. You'll get used to it. A lot of it will be hard to read, but you'll get used to picking up what parts of the code you were actually interested in. Hopefully that's useful for somebody who didn't raise their hand. And this is my point earlier. You can agree or disagree with anything I said. That's not the point of the talk. The point of the talk is think of the reasons why certain things that seem similar or certain things that are the solution to the same problem are different. So you can basically raise your hand and say, I completely disagree with all of the kind of prescriptions that I've given you to do something or not do something. But make sure you formalize the reasons why you disagree, or if you do agree, formalize the reasons why you do agree. Make sure you read your code, not only just straight after writing it, but also weeks later, also many sprints and releases later, and make sure that it still makes sense. So this is my point from before, where the purge of all of the types was perfectly fine the first few classes, and then when the code base grows, you go, okay, maybe this is not so great. This is why coding guidelines are crucial, and I'm really, really thrilled that JetBrains and Google as well are releasing coding guidelines for Kotlin, because a lot of the teams working with new languages, they start experiencing these teething issues where you're not really agreed on how you're writing code. You're basically just committing something that sort of works. So minimizes the bickering. We all know when that happens, when you have an argument that basically doesn't contribute or take away from the feature that you're implementing, but still you have to agree to it before you're done with it. And then refine the coding guidelines. So if you set out to write coding guidelines and you're done, you've implemented them, but then after months and months you're seeing that something isn't really working anymore, don't be afraid to change it. Don't be afraid to just throw it out and do a minor refactor or a major refactor, but basically rip off that Band-Aid before it starts impacting you and the rest of the team, if your team is large. What about future releases? Well, it's the same process. That's the point of not prescribing a solution to things. If there's a new version and you know how to approach these things, you know you're thinking critically about how to decide how to do things, then you're going to approach it in the same way with future releases. And JetBrains, let's face it, is a company that does take feedback well. It's not really, like some bigger companies that you can raise as many radars as you want, but nothing's going to come out of it ever. And honestly, this is what I found, again, in my own opinion, but I feel like Kotlin community is very much a Kool-Aid free community in the sense that it's not really a community of people who are fans of something for no reason whatsoever. Because the reason why that's true is because we all at some point did something that wasn't recommended. The backend developers tried Kotlin in production code bases, even though it wasn't the standard thing. Android developers tried Kotlin. I tried it before it was even version 1, which is risky when it's still in beta. But that's kind of why. As opposed to this sort of Stack Overflow comment from back in 2009, where this person is trying to argue that Objective-C in iOS world is a completely different type of language that doesn't need generics. Generics are all just for languages like Java and C#. And then Swift happened, and then they got generics, and then they were really happy with them. So that's the kind of thing that I haven't seen in the Kotlin community, where somebody just goes, we're doing this just because the big company said so, which is great. And last point is the performance argument. What I said before, balance it with readability, but also don't make empty statements. Don't go, why did you do that? Oh, because it's faster. It may be, but prove your point with decompiled code, prove your point with benchmarks, with whatever your platform, if it's Android, if it's backend, offers for that kind of thing. Conclusion, basically the same thing that I've been saying this whole time. Don't stop refining your code. Looking for a better way is not just wasting time, valuable project time that you could have spent implementing new features with bad code. Balance performance with readability, and don't be afraid to disagree and know why you're disagreeing, and formalize the disagreement so that people coming on board know that you've already had this discussion. And with that, I'm done. Thank you very much.